15 files while one of my presenters copying his files. Let's start session 4C. This is a visual analytics. This session will discuss innovative visualization tools and methods which can be used to address the transportation challenges of today. So today we have 4 wonderful presentations. Thanks for waiting for the last session. First presentation, the Tingting Huang from Iowa State University. She is going to present implementing data quality assurance with visualization tools.
Hello everyone, I'm Tingting Huang from Iowa State University. My topic today is implementing the data quality assurance with visualization tools. So we are facing and dealing with data every day. No matter the researchers or engineers, many research studies and applications are data-driven. So before we're using this data, the first question is what's the quality of that data? So that's my topic here. We want to assure our data is good and we will remove any noise in our data to create a better study and application. So in Iowa, we have two sources of data. One is the roadside radar sensors, and another is the probe data set. And in this study, I'll do 2 separate subjects. One is for the radar sensor. We have developed self-health monitoring on the radar sensors, and for probe data, go to the real data availability on the probe data. So at the bottom, we can see a radar sensor example, and in Iowa State we have over 400 radar sensors, mainly on the urban interstates. And for URIX, we have a better full coverage of the whole state. Yes, so the problem here is we want to answer what the data quality is. So there are basically 3 aspects. First is the completeness, and second is the accuracy, and the last is for probe data only, it's the real-time availability. And as I mentioned, we have 2 different types of data. We will do it separately. And for radar sensor, it could provide your speed and volume and occupancy. But for URIX data, the probe data will only have speed in them. So let's talk about how we produce this. First is the hot topic big data. Because data is growing every day. So in our lab, we use the raw data in high resolution, which is 20 seconds interval. We pull out the data from the URL, which is provided by the vendor, and download it and store it in HDFS, which is a Hadoop distributed file system. This platform is very powerful. It can enable the HPC, which is high performance computing. It's different from the traditional computing where you need to dump all the data in a RAM, in a single RAM. This file system can parallel process a very large size real data. And after we calculating and storing those data, we output it to Tableau and create our own visualization on a daily basis and in real time. So basically, now this process is fully automated. We schedule the program running every night in the middle of midnight, then refresh the visualization every day. So after we build up the system, we just need to care about where your data source is. We don't need to worry about all this process now. So for the radar sensor, because we didn't compare it with URIX data, we just use the self-health monitoring, so we need to conduct an algorithm to check the sensor data accuracy. We have a different category in this radar sensor quality, and each category has different type. I know it's kind of blurred because I cannot see it from my side. So first type is the raw data error, because we know sometimes the raw data is noisy, and sometimes it can error like a negative speed, or if you have 0 volume but you have positive speed number, then we categorize that as raw data error. And we also check the downtime summary for the sensors, because the sensor will report you the status of it, if it is off or failure or just simply missing data. And we also check the volume and the speed distribution generated from that sensor to see if it has an outlier, is extremely value in that data set. And the last part is the performance we calculate. Basically, we calculate the volume and the speed difference between two adjacent sensors. So on freeway, we assume that there shouldn't be big difference between two sensors. So we also calculate this difference. The last one is the vehicle length error. This is employed by the previous literature for the loop sensor error detection. We use the volume, speed, and occupancy data to calculate the average effective vehicle length, and this number should lie in 10 to 75 feet for a single vehicle. So any data outside of this range, we flag it as an error. So let's go to the visualization part. This is for radar sensor. First is the completeness. We developed the two dashboards for the completeness. The left part is for the electronics system check. There's 3 panels in the dashboard. The top one is the overall percentage of data you're getting every day. So you can quickly look into this line to see which day you may have lost a lot of data. And the middle part is the number of records per hour. So basically you can look where your data is losing. And the last part is the number of operational sensors in every day. So basically you can see the green bar means the number of sensors has over 90% of operational data. And the red bar means those sensors are basically only have less than 10% of operational data, which means they are maybe turning off or failure. If you click on those bars, you can also see the location of those sensors. Basically, those red bars are some work zone sensors because they are temporal sensors. Once they are finished, they will remove it. They won't report any data, but that sensor name is still in the data inventory. So that's the problem. We need to talk to the vendors and let them to remove those retired sensors. And the right part is a sensor level data completeness. We rank all the sensors with the missing data rate. So you see the list of those sensors. If you click on any number of sensors, any name of sensors, or the day of that sensor, the bottom one will show the detail of that sensor. You can see this sensor I selected had lost over half the data in that, I think is July 17th or someday. And then the blue area means operational, and the orange area means failure. Then that sensor starts failure from that day. So this is the problem in the sensor. We can report this also to the vendor to let them to check this sensor. For the accuracy, we use the algorithm I just described before, and we developed this visualization. This is the overall view of the dashboard. We have some measure selector on the left, because we have so many measures. We want to check them one by one. And once you click on a measure you selected, then the display panel will show the chart for that measure. And on the right side, you have a sensor selector. You can select any sensor on any road direction or based on the ownership. And also, we provide a speed heat map for that sensor. If you click on the sensor on the map, then at the bottom right, you will see the speed heat map for that sensor. First is the raw data arrow. We click on the measure selector of raw data arrow. We can see 3 different types of raw data arrows by day and night. And we also can select the downtime summary. For this sensor, we can see lots of failure in this sensor, and most of them are happening in nighttime. And we also can check the speed and volume distribution by time of day or day of week. There are two dashboards. I just labeled them. If you see an outlier in your speed data and all your volume data, you can identify the problem. And we also summarize the vehicle length error. Here is the difference we calculated between two adjacent sensors. In this graph, the speed heat map is showing from bottom to top. This is the travel direction, which is the northbound direction. We select 4 sensors. You can see the second from the bottom has low speed all the time compared to his neighbors. Then you check the left chart. You can see the speed difference drops down at that sensor, then go back at the next sensor. So we can identify the problem happened in the second from bottom sensor. Also, we output all the rankings of those sensors every 2 weeks. So for the IRIX data, we do 2 things about it. First is also the completeness. This is a similar with the Viltrox data. We have a dashboard for the completeness. First panel is the overall percentage we are receiving every day. And the second one is how many sensors have already complete over 95% of the data every day. So you can see in the middle, there's one thing, most of the sensors doesn't have enough data. And other days, they have sufficient data. And at the bottom left is the map. You can click on every segment, then the detail will show in the bottom right. Like here I select 2 segments. For the top one is interstate segment. We can see the blue area means high quality data, which is score 30 in IRIX, which means it's a real-time data. And the orange area is the score 20 data, which is the combination of your real-time data and historical data. And the red area is score 10 data, which is pure historical data, it's not real-time data. So we can see for interstate segment, most of the time you can get the real-time data. But at night, you only get historical data. And for a non-interstate segment, most of the time you are not getting the real-time data. It's just historical data or documentation. The data quality is not as good as your interstate data. Regarding this, we have a specific dashboard for the IRIX data, real-time data availability. This is the yearly summary for all the IRIX TMC segments in Iowa. This is the data from 2014, and the segment is colored by the percentage of real-time data in the year. So the green color means you have over 90% of real-time data throughout the year. But the red color means you have less than 10% of real-time data. So basically the same thing we can see here. In Iowa, I don't know how you know about Iowa. So the green horizontal line is I-80, and the vertical line is I-35. And on the left is I-29, and we also have I-380. Those green lines are basically only interstates. But your arterial, your other roads, they only have very less of real-time data. So you may want to know, when you buy those data from IRIX, does it really give you the real-time data always for all the roads? You need to check this before you run any application or research which you require real-time data. You need to select those routes with a high percent of real-time data, which is good quality data. Okay. Yeah, you can also click on each bar to see where those segments located. Here is less than 10% of real-time data. Those segments are basically local streets. And also in the west-south bottom of Iowa, we don't have much of good data there. So this is hourly summary. We can also do daily summary, hourly summary. Here I select hourly summary to see the time variation. And here I select 12 a.m. So throughout the year, at 12 a.m., most of segments are not providing any real-time data. This is reasonable because the probe data depends on the probe variables. If we don't have that enough volume in nighttime, we don't have those real-time data. So you can see the red bar is very high. We don't have enough real-time data. And when we shift to 8 a.m., so the traffic starts, you can see basically the interstate are getting real-time data now. And for other rows, it's still in the half. So my study here has two parts. First, we need to run algorithm on radar sensor data to check the completeness and the accuracy of those radar sensors. Then we can report it to the vendor every week or every 2 weeks and let them to schedule the troubleshooting of completeness. And for the index data, which we mainly use it for the researchers. If you want to do anything related to real-time data, you better check this first to set your target at the right place. Otherwise, you won't have the good data to run your model. So that's my study here. Thank you.